रोहित जी लाइव स्ट्रीमिंग ऑन करिए, रोहित जी लाइव स्ट्रीमिंग ऑन करिए। मैम कंटिन्यू करिए आप प्लीज।
Okay. Good evening, everyone. I, Dr. Akanksha, welcome you all to the 15th day training program. We are truly blessed with your presence. The world is full of diamonds and gems, and we are having some of them here today. Yes, I'm talking about the famous scientist, Dr. Sunita Chaudhary. Dr. Sunita, before starting the program, I would like to brief you all about the Sunita ma'am. Dr. Sunita Chaudhary, an agriculture scientist in system analysis for climate smart agriculture at ICRISAT, Hyderabad. ICRISAT, as we all know, is an international agriculture research organization which works for semi-arid tropic of India and Africa. Dr. Chaudhary has completed her graduation from Indira Gandhi Agriculture University, Raipur, and post-graduation in plant breeding and genetics from Chaudhary Charan Singh Haryana Agriculture University, Hisar. She did her PhD from ICRISAT and postdoc from North Carolina State University, USA. She also did attachment program at University of Florida and Kansas State University in USA. During her postdoctoral program, she played significant role in the release of 17 drought-tolerant maize hybrid called Aquamax in industrial partnership with Pioneer International in USA. Dr. Chaudhary is crop physiologist by training and work toward abiotic stress adaptation with special focus on translating the knowledge gained in high throughput phenotyping for drought, salinity, and heat tolerance. She also worked extensively with different sensors used in nutrition and precision phenotyping. She is DGCA certified first women drone pilot in Telangana, and from past 5 years trying to advance the UAV application for sustainable agriculture. So today, Dr. Sunita ma'am delivered her lecture on UAV-based digital phenotyping for managed stretch environment, potential to alleviate efficiency in precision farming, precision agriculture. So now I would like to request Dr. Sunita ma'am, please come and enlighten us with your knowledge.
Thank you, Akansha. Very warm welcome to everyone and greetings from ICRISAT. I hope my screen is visible, the shared screen, and I'm audible. Can you confirm, Akansha?
Yes, ma'am. Yes, ma'am.
Yeah, so let's move ahead without wasting much time. I have already given one lecture, so a little bit talk about myself. So probably I'll not repeat today. So today, in fact, in this whole week, me and my team will be going to enlighten you with a lot of knowledge on precision agriculture, precision phenotyping, precision farming, smart solutions. What are the technology available for this? So I'm starting with UAV technology, but my team will be also starting with other technologies. So I request please be attentive on this week, actively participate. And if you have any question, we are very accessible, very reachable. And ICRISAT is always has the goal to strengthen the national systems and train and build the capacity building. So in this aspect, we are always actively participating and collaborating. So anything apart from this talk, if you have further doubts, you can reach us anytime. So let's start the presentation. So as everybody knows, I'm going to talk about UV-based digital phenotyping for managed stress environment, potential to elevate the efficiency in precision agriculture. So in last 2 weeks, you might have learned a lot about the precision agriculture, and I think you are very clear with what is main domain of precision agriculture. So I'm not able to move. Yeah. So if I have to little bit elaborate, recapitulate that what is precision agriculture. So it's a basically technology enabled approach to farming management that absorb, measure, and analyze need of the individual fields and crops. So it's important that you learn what are the main pillars. So any technology added solution you give for farming, for traditional farming or for normal agriculture solutions, this all comes under precision agriculture. Whatever can improve your productivity, whatever is time and cost effective, whatever technology can take you to a higher level of agriculture predictions or knowledge or forecast, that all comes under precision agriculture. So precision agriculture is not very new. As I said, only this slide I will repeat from my previous presentation, that is, it is as old as launch of satellites. So when satellite came in picture, that very same time precision agriculture also exists in our dictionary. So initially it was only thing, with time we have magnified, we have improved the understanding of this, and we brought a lot of technology in our agriculture system to aid the solution. So in that time it was only those global positioning systems were mainly understood as a precision agriculture, and if we can make forecast over that. Later in 80s and 90s, availability of satellite imagery and all those remote sensing started upcoming. Remote sensing itself is a Pandora box. If you open, there are a lot of things can be done, but slowly it has been taken up, and still it is going higher, but main challenge is validation, and drones can be an easy solution for localized validation of all the remote sensing applications. So it started in 80s, 90s, and 2000 onwards. Precision agriculture all means sensors, drone, autonomous vehicle, advances in data management and analysis. So two main pillars: hardware side on this all robotics, and software side all AI, artificial intelligence, is a part of precision agriculture. So in this, it is predicted that drones are going to be a larger part of third revolution in agriculture, and in few moments we'll see how. So moving to the next, this is the prediction. Allied market research has been published by North America, that drones, agriculture drones are going, precision agriculture will be the major part of the agriculture drones. So there is a lot of scope in precision agriculture for drones compared to any other area which is developing with the drones. And we see a lot of scope with that. Second, in drones, what are the components? So there is a hardware and there is a software. So here you see in 2020, hardware and software is a little market for that, but in 2030, it is going to be very big. It's almost 5 to 8-fold increase is going to happen in hardware side for drone, but also on software, there is a tremendous increase. So a lot of startups which are growing with hardwares, if smart startup, I would suggest also invest here in software, or if you are projecting yourself as a business person in future, do not ignore this area, because hardwares can develop up to an extent in recent future, but in larger future, longer future will depend on the software. So how smartly you can extract the information out of this hardware is your software. Also by, I don't know if whole slide is visible, this is something bothering me. So scope of drones, if we see continent wise, then also that Asia Pacific is going to be very large with the higher GDP. So it has a lot of prospects in our country and Asia Pacific, all the countries in Asia Pacific to grow with the drones. So agriculture drone is not something we can ignore, neglect, or take it slow. So who will be your stakeholder in case if you are thinking for this? All the research institutions, all the crop research stations, seed companies, agrochemical companies, university, academia, contract farming, crop insurance, all are going to utilize drone very soon in their larger part of their domain. So very simple example I always give just for fun. So telephone, when it came, it was only used for talking, but later it has people were parallelly working on other application, and what we have today is a smartphone which can be used for many other purposes. It's not just a device to talk, but it is a device for many things. You can do banking, you can do message, email, photography, direction, whatnot. So similarly, drones are also at present it look like a farm equipment, but in future it is going to be much more smarter in application, and it will be utilized for many other purposes. So maybe this will be the future where you will see drone application in much larger scale. IoT, it will be connected with many other farm machineries and utilize in larger scale. So at present, India, because of the legislative things, in 2020, it has been removed, all the restrictions, and we started because government realized that we are getting back in this technology where other countries are growing well and there is a lot of scope. So they gave a lot of leverage for research organization and also for startups. So there is a big boost for this for research and also for startups. So government itself has taken Kisan drone initiatives. They have also given subsidy on purchase of these drones. Also, they are establishing custom hiring centers. So between 5 or 10 villages, there will be one custom hiring center where drone will be there and pilot will be there, and people can go and request or contract them for their spraying and different agriculture mechanical applications so far. And a different SOP, which chemical to spray, what scale, all this are getting released from government. Also, at present, India is using drones for surveying and monitoring, land mapping, law enforcement, and photography. But whether it is enough, what we are doing with drone, whether it is enough. So it's all are the standard application, spraying, surveying, monitoring, and this will only lead to the mechanical advancement. We will advance in mechanical applications in agriculture, and drone will end up as a farm equipment. It will be sitting in the backyard of farmers where it can be used for the farming, different mechanical application. But whether it is enough, as I was saying, smart drones, whether there is a scope for smart drones, if yes, then what could be the advanced application? So in a meanwhile, maybe I will explain what is first. So there are many unforeseen areas with drone agriculture which is not explored or explored at very minimum, or it's going very slow, but this has larger scope with the drone. So we are using it for climate resilient crop development. It can be used because it can handle the large phenotyping, scale phenotyping in field. You need not to bring the plants to specific testing site, glass house platforms, and any other. Drone sensors can be taken to field with this technology. Then yield prediction and insurance. In future, insurance is going to be big. Even government is Fasal Bima Yojana they are promoting. So under that, if we know what is the yield, if there is going to be yield penalty, then insurance are the good option and it can save the farmers. Disease quantification, tracking of disease outbreak, pest outbreak, drought forecast, it can be taken. Soil nutrition and soil health can be also predicted, quantified, or monitored through the drones. Farm input optimization, if this turn out as a smart drone application. You can optimize like how much nitrogen, urea to be applied, how much, when to irrigate, how much to irrigate. All this kind of optimization can be done, and farmer has reduced input for their field in spite of applying a lot of fertilizer. They can minimize it, because if they are not going to give additional benefit, then they can minimize and they can save the cost. So this can help in farm optimization. It will be probably developed as a web application in future, and it is not very far. Very soon, this all applications are not dream, it will come in a real. Also in data collection, Karnataka government has spent 4,000 crores for just agriculture data collection for which crop is grown where. So this in future very likely is possible through drone with very easy technology. Low height remote sensing, it can be used for validation of remote sensing data. In absence of validation, most of the remote sensing data is not getting utilized. So this can be used. This can also take hyperspectral. With remote sensing, we don't have hyperspectral options so far. Watershed mapping. So watersheds are growing, and the government is giving subsidy or projects for watershed development, and this can monitor, map those watershed. Digital public goods. So DPG is a initiative of government where they see a small unit which can be utilized for many other purpose. Simple example is Aadhaar number. Government has created Aadhaar number, but then it is utilized in many other purpose. So spectral signatures identified by drone, it can be a digital public good. So there is a big scope for that, and I was part of some of the high level meeting, and they were discussing all about this. So so I will only take you for one area where drone, because it's not possible to explore every other things, and where my expertise is there, and where I can give you some knowledge which is useful for your future. So phenotyping, I'm going to take the phenotyping. I don't know how to minimize this one, but yes, phenotyping is an important tool for accelerating the crop improvement, and you know it costs a lot. And all this, there is a big market for this. All field phenotyping is not easy. It is that's why those all phenotypings are either in glass house or at a smaller scale. When it comes to field phenotyping, there is not much technology. Most of the time, if you have to measure plant height, you have to take your scale and go to the field. There is no other technology. So technology is not touched when it comes to field phenotyping. And drone is a perfect vehicle. Where the other world has developed all this robotics and cobotics, which is $1 million expenditure, we can take it simply in a smart way is use of drone, where sensors can go to field. Only thing, you have to stabilize the algorithms or pipeline for extracting the data out of images or data out of those different sensors. So that is the challenge, but otherwise this, you don't have to invest on those infrastructures. So this is like a perfect vehicle for field phenotyping. But again, all the technologies are available, but it should be fit for purpose. It should be need-based. Sometimes big technologies are developed and we try to fit our requirement in that. We try to get those data which is not of our use, because there's some technology exists. Should be sustainable. It should be cost effective. It should be precise. If it is not precise and not long-term solution, then again, because of there is a boom of drone, we can use it, but again, it will be resting some corner of your storeroom. So we don't want that. So we need a sustainable solution. So all the technology, when you are choosing, you just pay attention that this should meet all these 4 criteria. Then it will be long-term and sustainable for you. So simple example of phenotyping in or you are all agriculture student, you know that in when breeder try to make a variety, it has to make a lot of process and which generate thousands of lines. Characterization of this 1,000 of lines in field is a major challenge, and we do up to larger extent very manually. It's very, even the scoring either visual or manual. So before you have to make selection out of 500 lines, then you need data. And data is getting generated very manual so far. So if we have to change from here to here, what we need? We need drone. And So at ICRISAT, what we are developing, we have established a drone-based field phenotyping platform. We use different kind of sensor, RGB, multispectral, and hyperspectral data acquisition facilities available. Then we do data storage, pre-processing, and then we extract the trait of interest. So this is also take time, and with all the IT supports, what we are doing, slowly we are adding the traits. So we are good with the number of traits, some 6-7 traits, but then we are progressing each passing day. We are adding few traits. We are working on different sensors and try to bring as much as digital phenotyping possible for field. So we are using, as I was saying, simple RGB sensors we are using for simple traits like plant height, plant count, canopy cover, biomass, yield. All those different kind of simple traits can be exploited with RGB. With multispectral, little complex traits like staggering, senescence, flowering, panicle, identification, different kind of all this we are using. And with hyperspectral disease score, insect infestation, early detection of water stress, nitrogen stress, because remember that when you complicate your sensor, you also complicate the image analysis process, and which take a lot of time. So if you have no reason to complicate the sensor, please use simple sensors, RGB, which is easier and more reproducible, because each time you don't want to take a lot of time to analyze those images. So to develop the pipeline, and that pipeline can be simpler with simple sensors, and it needs a lot of IT expertise to develop for multispectral and hyperspectral. So choose wisely what sensor you are using. If it can be resolved with simple sensors, use simpler form. In simple sensors also, analysis mode, 2D, 3D, this all simple methods can be tried first, and if accuracy is not achieved, then you complicate the models, what can be used. So not only image analysis, until your input data is standardized, your output data is not going to be standardized. So we first develop the flight SOP. So at what height you have to take flight, at what camera setup, what UAV setup, how much overlapping will be there, side overlapping, front overlapping, what environmental parameters, means how much sunlight, what wind velocity is not recommended, what image quality parameters, processing script and automation. So a lot of things we optimized first the SOP. So whatever images has been captured from 5 locations or 10 different trials, all the images should be coming from the same SOP, so that what pipeline I'm developing, the analysis is simpler. If suppose one place it has been taken at 8-meter height and another 16-meter height, I will have the challenges. So first, always develop the flight SOP so that your images captured from different location is synchronized. Second, image quality. Although you follow all the SOPs, then also it's quite possible in present weather condition that all the images are of not same qualities. Many times that images doesn't meet the quality. So then we develop the image quality metrics so that we can decide if image is of not good quality, you discard and retake the flight. If these 2 input parameters are not optimized, image analysis pipeline is not going to be the same. So this is the major hurdle in utilization of drone technology, image analysis, and for that we have to optimize the input data in that. So coming to the image analysis, it's a pipeline. It has many steps. Those who are IT students, they might be aware of this. But for agriculture students, we need to take help of IT people or those who are good in different language writing. So it has calibration, it has photogrammetry. Then you first you stitch the images, whatever has been taken at different overlap. You create a orthomosaic, and then you segment it based on the plots. You segment it, and then you start the extraction process, which is based on different models and different kind of parameters, like NDVI, leaf area index, and F powers, excess green. Different models are there. So because this is not a scope of present presentation, so I'm not covering that, but this is a big process in that. So first thing, you conduct this experiment when you are trying to establish an image. Very precise experimentations are required. Develop the flight SOPs, then ground truth collection will be required for initial development of algorithms. Once algorithm is set, you can take the prediction. You need not to measure any manual measurement, no ground truth is required. Then data processing has the process, which is pre-processing involves data quality control, robust model application. Then one important part which many of the startups and many of the researchers miss is the validation. Always take the blind validation, take the data from field or different years where ground truth is available and predict and compare with your manual measurement, how accurate. If you are not meeting the sufficient accuracy, R-square and RSMA, then you need to reform your image analysis, improve your image analysis process algorithms so that you can increase your prediction power. If prediction is not sufficient accuracy, then you are not producing the right data, and your customers or your researcher may go away because you are not able to give the accurate data with that. So once this is done, then one important process is automatic processing. Means you have to automate it. You have to develop it as a software so that it is user friendly. People can put their images, they get the trade prediction. So these all steps are there, but nevertheless it's a difficult, but it's not far. So few very short example. I know it is going little harder, but pay attention. It's interesting. If you drone is not a single hardware, but it's a software, and if you don't progress toward that, you don't keep knowledge of this, probably advancing the drone is difficult. So some of the user case I will brief here. So we always develop the image analysis pipeline. In that all the setups, SOPs, everything is mentioned. And then you tag your field, you run the precise experiment. Here for nitrogen we were doing, so we developed 3 blocks of treatment. First is well water and well nitrogen. Second block, you can see it's irrigated, but nitrogen has been not given, means urea application has been restricted. And third, you can see it's not irrigated, and but nitrogen has been given. So sometimes when they are water stressed, nitrogen uptake also doesn't happen, and you see the consequence of both. Similarly, this has been done in model crops. So sorghum, which is high stature model crop, and groundnut, which is short stature model crop. In groundnut, we have only given 2 treatment, water stress and well water, no nitrogen, because it's a legume crop and it has automatic nitrogen fixation, so it doesn't make sense of anything. So similar treatments were there and images were captured. So if you see different ground truthing data has been developed. We match the date of light, we match the date of ground truth data, and we try to predict those traits and see with the validation how much is good. So here the best model what we found is multilinear prediction and CNN, which is one of the AI machine learning model. And you can see the accuracy with the 82.9%, we were able to accurate the nitrogen level in sorghum, which is quite good. If you do by wet lab methods or with visual scoring, it takes a lot of time. And if with this much accuracy you can do, it's good enough for the initial. And we are also trying to improve it over time. This is just a glimpse. This is just, there is a lot of work. Similarly, canopy height, you have to measure. If you have 500 plot, you have to measure with a scale. At least it will take with 5 people, 3 days minimum. So we have developed these digital elevation models, DEM we have used, and with 90% accuracy, we are able to give the plant height in just 2 hours of flight capture and data predictions. So well, good. And it's a validation of groundnut is also very good. Similarly, for a case study of biomass, so for store quantity, you have to do biomass prediction. So this has been also predicted with quite high accuracy. You can see as the progress, this with the 90% accuracy, we were able. Little bit difficult for the sorghum, but then we are trying to improve it. Hyperspectral data, we were trying to, so hyperspectral can see what our visual eyes cannot see. Visual eyes, our human eyes are in, can see spectra in range of visible light, which is like somewhere after 400 to 1000, but hyperspectral can see beyond this. So we use hyperspectral sensors for early detection of water stress, early detection of nitrogen. If you can predict that one, you can supplement the water or nitrogen application well ahead in time. These are the advanced application, and with this also we are progressing and we have a good success with that one. You can see the spectra has been identified, which are responsible for nitrogen stress. So moving to next, like some of the pilot cases where multi-location trials were conducted in different region, and you can predict some of the traits. So you don't have to send the people to capture the data in those places. You can just hire the drone startup and give the SOP at that height, at that camera resolution. They will take the images, send it here, and you can predict all the biomass, canopy height. So developing a pipeline is a difficult, but once it is established, it's very easy, it's super easy. So drone application in phenotyping, we have success. You can see this manual transition can happen, which is a greater part of precision agriculture. So all these manual things can be overtaken. Similarly, a drone application has been well quantified for disease monitoring, disease quantification. This is sterility mosaic disease of pigeon pea, which we were trying to do with the, this technology. So disease can be done manually. You can see in a hardboard, you can write. And recently, mobile application have come, which can be also used. But if you have to do something on scale, then drone is the technology. So there is everything there. Every time there is a hierarchy of this, and then based on the options, based on the plot size, based on the investment, you can decide which technology to be taken. So here, yes, manual is, if you have less resources, you have a smaller field, this is the best option. With mobile application like Plantix and all this, that has also progressed well. But if it is a larger scale, drone is the best, and in future drone will be utilized in many, even in smaller scale also. Similarly, for nutrition, you have to take all this wet lab or this benchtop sensors you have to use. Recently that handheld devices have come, and next level of phenomics, next level of technology is drone, which will phenotype for nutritional trait right in the field. So this is also not very far. It will take some time, but it will be applied for sure. So this drone technology can be used for business solution. If you develop this all trait extraction methods, you can use it for your own business case. You can develop it develop it as a smartphone application. You can also tie up with drone startups. You can automate this process. So there is a big scope in that, and it will progress soon. So as I asked in the initial, what are the applications? So advanced application, yes, it can help you in technology aided transition of agriculture. So if we are all if we are agriculture community, what people are attached here belongs to agriculture, then these are the technology which can be used in future for your sustainable solution. This is like more than a mechanical solution, it's a sustainable solution which will be used for agri-system transition. That's why it is called that. It is probably one of the vehicle for third revolution, but it has time. We have to develop this all smart application before we reach and say. And sometimes it's not. Sometimes there is a big hype, but then technology that cannot be proven at that scale. So then there is a risk, but then we envision it as a great scope. So what are the other things? As I said, a farm input optimization, it will be used for fertilizer application and many other things. It will be also used by many insurance companies for yield prediction, so that proper insurance amount and premium can be provided. Drone corridors are coming up. Government is talking about this, BVLOs and all this. So in future, there will be established drone corridors. Although the application will be more for this delivery system, but it will come for agriculture system also. So nevertheless, our networking with drone-based organization, we are working quite swiftly with many different government, international and national organization for different kind of application. We are also giving different talk for creating the awareness, and many other networking we are bringing in. So with this, I would like to thank you all. And if you have any burning question, please take the leverage to ask these questions. Thank you. Hello. Akanksha?
Yes, ma'am.
Yeah,
It's true.
okay. Okay. Yeah, so I will take few questions. So one of that is like, what are the initial investments, and after that, what is the running cost of UAV application if we use an system, the community? So if you are part of a research organization, initial you can buy the drones at very subsidized cost. Um, Also, you can also import. So research organizations are liberated from the restriction of DJI drone import. So you can purchase, which is also a little bit higher cost, but then indigenous drones, because it's a new technology for our country, it is costlier than DJI. So, and DJI provide a little bit more standard applications, so easier to and compatible with many softwares like flight plans, GSI and all this. So that is better. The second thing is like, yes, drone cost plus sensor cost. So anything between 5 to 10 lakhs you can invest, and it can be a long-term solution for yours. Maintenance cost is very, very less for drones. Is ECRISAT offering training crop modeling softwares with the drone training? Yes, we have recently developed a business case for this. ECRISAT doesn't offer directly, but it's offered through, we are doing some tie-up with drone startups and they will be helping you. But if it is a collaboration basis, not business basis, then we are open for any kind of collaboration and strengthen the national systems. Good presentation, nice presentation. Thank you. Microclimate these days. If not, is it possible to do so in future? Yes, why not? But we have a lot of weather station and micro weather stations. So I don't know if drone is a good technology to leverage on microclimate monitoring. Yes, somebody has asked Karuna, ma'am, what would be the yield estimation by the use of this technology? Yield is a complex, and which crop it decide which crop. So if it's something legume where the pods are inside, it's very difficult. But if it is cereals where panicles are outside, it's possible. In cereal, in maize where the cob is inside, like at lower height, people are still figuring out whether it can be done. So it has a lot of hiccups, but yield estimation for some of the crops are very easy peasy, and it will be done very soon. Custom hiring centers, yes, government has stabilizing and also giving subsidy for this custom hiring centers, and at village level and village programs, you can Google it. It's taking place. So they have given this responsibility to KVKs, Krishi Vigyan Kendras, and they are responsible for establishment of custom hiring centers. In those custom hiring centers, there are a lot of drone pilots are getting hired of, like, or getting contracted for those custom hiring centers. Yes, Aikar Atari Lucknow is working on many different applications like nozzles, spraying or solution, nano urea, nanoparticles. They have developed a lot. They have done a very good job. So they have developed a lot of different kind of nozzles for herbicides, pesticides, fungicides, sprays, which is slightly different in their shape and particle. So this is like a small differences, and they have made it. Is ICRISAT offering any diploma course in precision agriculture? At present, no, we don't offer. We are a research institute. We don't offer, but we do organize different training. And recently with Telangana Aviation Academy, we are developing a course for spraying and different flight SOP image acquisition, which will be launched very soon. We are very close to tie up to close the agreement with TSAA, and it will be offered for many different students. Subsidy is 100% for farmers and 80% for startups. You can type it in Google, or you can go to Ministry of Agriculture and Farmer Welfare. This is all elaborated. Even for women pilots, there is a good subsidy on drone purchase. So you can Google it, this percent of subsidies.
यदि किसी व्यक्ति की कोई क्वेरी है तो आप प्लीज अभी चैट बॉक्स में लिख सकते हैं, मैडम उसको रिजॉल्व करेंगी, क्योंकि ऑलमोस्ट लेक्चर खत्म हो गया है, केवल ये डाउट क्लियरिंग सेशन चल रहा है.
Yes, farm holding size. So one question from Sanjay Kumar is, what is the future of UAV technology in India, where the farm holding is very small and farmer is completely uneducated in computer, etc. techniques? So yes, farm holding size is very small. Therefore, this all mechanical applications will be hampered in future. And even there is a great example where they were trying to spray one pesticide in one field, and due to drift, it has reached to another field. Also, drift has a lot of health hazard. Therefore, government has released the SOP, what chemicals to be used for spraying. But that's why government is taking steps. It all need not to be done by farmer. They are establishing all this custom hiring center. They can, at very minimum cost, they can hire the pilot and also drone for different kind of spraying, and these pilots are trained for precise spraying. Therefore, Atari is working on Atari is working on different kind of nozzles so that the drift is less. Also, the height of spraying, different kind, or there is a SOP release when wind speed is more than this. So what we have our Indian national system has this kind of setup. So we have to develop the technology to beat those. We cannot imagine some other countries where farm holding size is bigger. So what are our challenges? We develop the technology, or we modify, customize the technology in that way, and it can be used. So what are the software? There are different software, either the fully developed software like AG Soft Metashape or Pix 4D, you can use it, but then you don't know in background what analysis they are doing. And if you are happy with that, you can subscribe those kind of software and you can use it for phenotyping corrector. But we develop ours. We try different models, and then we write the Pythons for this different kind of scripts. We use at this stage, we are using different small software like for orthomosaic creation and all this, but not as a complete solution. We are not using any software because we want to know that what is happening. So our target is very simple. First, try simple sensor, try simple model, and if that is not developed, not bringing you complete accuracy on the prediction, then you go for complex sensors or complex analysis model. In software, you don't have option to choose your model, choose your algorithms, because whatever is fixed, you have to take it. So that's why we are trying to develop our own model and see how much simply we can do, and then we automate it that through the different interfaces like Python, or different kind of scripts are getting developed. So we are not dependent on all commercially available software. We are trying to develop our own so that we can distribute it without any IP issue, and we can work with national partners on this. Yes, for contract, India is going towards contract farming. Therefore, drone is useful for future generation. Yes, I 100% agree. So in future, this contract farming will be converted as a drone farming. Actually, how much chemical is being wasted by the drift at the time of application? I'm not the right person for this question. Probably our experts from Atari can answer, but they are trying to develop the nano particle of spray so that in very less, like they were saying that in 500 ml, they can spray the whole acre of the land. So this kind of test, if they have done where they spray and how much has been wasted, I'm not sure, but I'm not fully aware on this quantifications.
अब कोई भी क्वेश्चन चैट बॉक्स में नहीं है मेरी समझ से.
Yeah, only one is left, like whether a technology is suitable for horticulture crops and vegetable and flowers. So sometime back we did the workshop where we called all the MNCs companies for flower, floriculture, for horticulture and agriculture. All seed companies were part of that. And in fact, more than the seed company, this vegetable, horticulture and vegetable companies came forward for utilization of drone in different way. Not only the mechanical spraying and all this, but they want to quantify, like in cabbage they were saying, and cauliflower they were saying, the color is their economic value trait. Like they want to quantify it, that, and scoring takes a lot of time. And for scoring also, they cannot deploy many people because person to person scoring differs. So they have to only maintain few people and train them very rigorously to see the same level of color. So if this can be optimized with drone, they came for this, all okra growers came, tomato growers came. This technology will be more taken up by vegetable. I foresee like this than the seed companies. Okay, I think I have finished all these questions.
हाँ जी मैडम, ज्यादातर जो भी क्वेश्चंस थे, एक एक क्वेश्चन को आपने जो है बिंदुवार उसका निस्तारण किया। बहुत बहुत धन्यवाद मैडम। आज बहुत बढ़िया जो है 2 वे प्रोसेस रही कि आपने पीपीटी को प्रेजेंट किया, इसके बाद जो जो हमारे पार्टिसिपेंट्स के क्वेश्चंस थे उन डाउट को आपने क्लियर किया। बहुत बहुत धन्यवाद मैडम सेशन को ज्वाइन करने के लिए। आगे आने वाली इक्रिशेट टीम के लिए भी हम जो है शुभकामनाएं देते हैं पूर्व में कि आपकी जो टीम है वो बेहतर आपकी तरह ही परफॉर्म करेगी। बहुत बहुत धन्यवाद मैडम।
They are expert than me, so just
जी
be assured that they will perform.
जी जी जी, थैंक यू मैम, थैंक यू।
Thank you, everyone, and have a nice evening and good night.
गुड नाइट, ऑल कैन लीव।